Why don't we learn about variables?
Let's say we have a value 42. What does this value mean? We know that it's a number, but what does it represent? And we have even an unofficial term for those type of values. We call them magical values. They appear here and there in your code base, and you need to try to figure out what they mean. And this is a problem number one. The problem number two, if we want to use this value in an expression, let's say we want to double it, the only way to use it would be to copy this value. So we copy and we multiply by 2. There is no need to have that. We know that 42 times 2 is an expression. An expression will be evaluated to a value. If we want to use the value that is produced by this expression, we would need to copy it again. Let's say we do 42 times 2, and then we want plus 5. It would be really hard to write code like that. Also, this expression is not evaluated to a value until we are hitting the line 2. Here, we don't really know yet what the value should be. How can we solve those problems? We can declare variables. You could say that variables, they are labels associated with a value. Let's try to use a var declaration and assign a label to this value. Var meaning of life equal 42. We declare a variable and we associate a value with that variable. We now can use this variable interchangeably with the value it represents. We create another variable that will be meaning of life times 2. Then we can do, you see, we solve those two problems we have mentioned. First of all, we know that 42 is not just a magical number, it represents a meaning of life. And then we can use it in expressions, even though it will be evaluated later. Let's see another example. Let's say we have a variable, and then we have, now we can create another variable. If we're gonna print this value, and we got James Holden. Some variables can be reassigned. We're gonna see later which one we can reassign and which one we cannot reassign. So variables that can be reassigned means that we can assign a new value to them. Let's try to do that. So now if we try to print, what? We got James Holden back. Why? Let's try to understand what has happened. Let's say we had a string, James. James is a string and it exists somewhere. It doesn't matter where it exists, but it exists somewhere. So there is a variable first name, and that variable is associated with the value James. So we can use either James or the first name because first name is James. Since first name kind of points at that value James that is somewhere. Holden, last name is associated with the Holden. So afterwards, we have created a new variable called full name, which has first name plus space plus last name. Full name, it points at evaluated expression. So try to see where first name points. It points at James. It will be James plus space plus Holden. And then it's evaluated using addition operator, and for the strings it will combine them together into a one string. This James space Holden will be a completely new string value that exists somewhere, and variable full name points at this value. Afterwards we said, okay, let's reassign a first name. First name points at Amos. As we can see, it doesn't point at James anymore. What happened to James? We don't really care. What we care is that first name now points at Amos. We said that last name will point to Burton. So now last name points at Burton. But then when we, on the line 7, when we printed full name, we still get James Holden back. Why is that? Well, because full name is still points to James Holden. We didn't set it to point at anything else. And this happens because first name and last name and full name, they all point to primitive values. So when we reassign one primitive value to another primitive value, the variable will point to a new primitive value, full name is still points to this string. In order for it to point at something else, we would need to repeat this expression, and then we get an Amos Burton back. There is a little bit of a difference between when we talk about primitive values and non-primitive values. You remember that we mentioned that there are 7 types of primitive values and there are 2 types of non-primitive values, which are objects and functions. I'm not going to show you just right now what happens to non-primitive values, just because it then becomes a little bit trickier and we will explore it in another video. But what we will talk about in this video is that we learn about that there are 3 ways to declare a variable, with var declaration, let declaration, and const declaration. So we have var x equal 1, let y equal 2, const z equal 3. In order to understand the difference between these 3 declarations, we need to talk about scope. I'm thinking that the best way to talk about scope is to imagine some kind of pyramid that has floors. There is one rule about those floors. Those who are on the lower floors, they never look up. They cannot see anyone above them. But those who are on the upper floors, they can look down. Right now, all these variables here, they are in the global scope, which is level 0 of our pyramid. So we have x, y, so we have var and y. They are on the level 0. We can define a scope using curly brackets. It's also called block statement. We declare here a variable let a. I'm going to explain the difference between var and let a little bit later, but will be equal to x. You see, there is no complaints here. We don't see any errors because a can see x. Well, it's because we can draw another level. If we imagine those levels or scopes as this pyramid, a is on the first floor while x and y on the 0 floor, meaning that a can look down and can see x and y and it can refer to them, but x and y, they cannot see a. So if we try to use a here, we will get this error, a is not defined, because y is like, who is that a? Where is it? Let's say another scope where we have a variable b that can point to a. It's another floor, level 2, and variable b can see a. It can also, by the way, see x and y because they are lower. So we can also say b equal a, or b equal y, or b equal x, and there is no complaints. Variables can look down and see those which are on the lower floors. And our floors in the code base, they are defined by these curly brackets, by these block statements. So anything within those curly brackets, they are on their own level. So there could be several scopes that are on the same level. B and C, they are on the same floor, so they can look down. First of all, let's see the difference between var declaration and let declaration. So if we declare C as let declaration, we cannot use it here. We get here C is not defined. But if we change C to a var declaration, do here like x, because variables on the same level, they can see each other and they can see on the levels lower. So y can see x, but now, surprisingly, because we declared C using var declaration, x can now see C. Let's use just b, we get an error, and then we use var. So now we can see var b. How does that happen? It happens because var declarations, they are hoisted. So what happens is that JavaScript code is executed through 2 passes by the computer. So first of all, computer reads through the whole code, and if it notices that there is a var declaration, it becomes hoisted. What happens is that it knows about var b here, and that's why x can see b variable, because it can see on the same level. The question is what exactly value it will be pointing at, because var b, let's say it will be 5. So if we print x that points at the b, we get undefined. How come that happens? Well, it is because it's assigned value only here on line 9. So what happens is that we have a variable x, y, a, and variable b. Where do they point? We know that b will be pointing at value 5, but it will be pointing at value 5 only starting from line 9 of our code. Every variable is always initialized. If you don't point to a value explicitly, like we do here when we say equal 5. Variables, they point to this special type of a primitive value, undefined. We have said that it's own type, and this type is for unintentionally missing values. So all variables, they are declared with that value or pointing at that value until they will be explicitly assigned to some other value. So until this line B, because it was declared through var declaration, because it was hoisted, it will be pointing at undefined until line 9. But we use it already here. So we say that X is pointing to the same value as variable B, which means that it points also to undefined. So when we print it, we get undefined. Same happens to Y. So if we print Y, we also get undefined because Y points at X, and we know that X still evaluates to undefined because it points to B and B points at undefined. A totally different story happens to a variable declared through let declaration. If we change B to be declared as let declaration, we get an error. B is not defined. That's because variables declared through let declaration, they are also hoisted, but only to the beginning of the scope they are declared within. Let's say X is pointing to 1. We know that let A can point to X. It's gonna be perfectly fine. We can use it since it can look down and see X is pointing at 1. But we can reassign X point at 5. Console log still 1 because it is printed on this line, and on this line A becomes evaluated, and we know that it is same as X. X becomes evaluated on this line, and we know that it points at 1. So even though we initialized later to 5, same as we had with the James Holden, we still get printed 1. But as soon as we add let and we redeclare an variable X using let declaration, we get this error, cannot access X before initialization. And what happens here, temporal dead zone. Temporal dead zone is basically the following. We said variables declared with let declaration, they are also hoisted, but only to the beginning of the scope. So what will happen here is that let X will be hoisted here. That's why A can point at X. But comparing to var declared variables, let declared variables, until they are explicitly assigned value, they are considered to be in this temporal dead zone. So for the variable X, all these lines 3, 4, 5, and 6 variable is in the temporal dead zone. Even though it's been hoisted, you cannot use it because then you will get this error, cannot access X before initialization. If we do not redeclare a variable X, we can still point at it. Variables declared with var declaration don't have this temporal dead zone rule. Finally, we said that there are a const declaration. For the const declaration, it's sufficient to say that they behave almost like let declaration, except they cannot be left uninitialized, because we said that when variable is not explicitly initialized, it points at value undefined. So it actually kinda initialized, but it points at value undefined. But const declared variables, we cannot have it left uninitialized, saying that missing initializer in const declaration. It is because variables declared with const declaration, they cannot be reassigned. Meaning that if we assign some value to X, let's say it will be 5. X is pointing at 5. So after that, X cannot be reassigned. We cannot say X equals 6, for example, because we get another error, assignment to constant variable. So this magical link between the variable and the value for the const declaration, this magical link can be set only once and then it can never be changed for that variable. In this video we covered a lot. We have seen how you can declare variables through var declaration, let declaration, and const declaration. We briefly touched on the difference about them. We talked about scopes, we talked about hoisting, we talked about temporal dead zone, but at the same time we only touched variables that point at primitive values. So in the next video I'm thinking we're gonna take a look at what happens to the variables that point to non-primitive values, which means that we will take a deeper look at the objects. And also I will leave a link to the exercises in the description below. So see you in the next video.